Let's try that again. Record. 2.5 variation. Good. All right, so we're going to construct a model using direct variation, construct a model using inverse variation, and construct a model using joint variation. What direct variation is saying is that as one thing goes up, the other thing goes up, right? What inverse is saying is that as something goes up, then the other thing is going to go down, the opposite, right? So that's just the gist of it. And then joint means that they're both happening. We're going crazy. All right. So for direct variation, we're saying that something is directly proportional or there's a constant of proportionality, okay? So our constant of proportionality is our K value here. So it's Y equals K times X. So that means that the situation I'm describing can be set up as Y equals K times X. And K is our constant of proportionality. It's our ratio of some sort that is taking place. All right. So the key thing here is Y equals K times X, and K is our constant of proportionality. It's basically a ratio. Capiche? Awesome. The full Y equals K times X. Okay. When we say that it varies directly, we're saying that, as you can see, as the independent variable increases, what is the dependent variable doing? It also decreases. All right, and vice versa. If my independent is decreasing, then my independent is also decreasing. They increase together. We're growing together. Okay. Okay. Simply put, your constant of proportionality, your K is just your slope. Easy enough? K is just your slope. All right. So what turns it into this is that we are dealing with word problems. All right. So here we have the monthly payment P on a mortgage varies directly with the amount borrowed B. Okay. So that is telling me that there is a direct variation. So that means I am multiplying something by something, right? That's the key thing here. The fact that it says varies directly leads me to know that I am multiplying. Okay. All right. If the monthly payment on a 30-year mortgage is $6.25 for every $1,000 borrowed, find a formula that relates the monthly payment P to the amount borrowed B for the mortgage with these terms. Then find the monthly payment P when the payment borrowed B is $2,000. 200,000. Yeah, that. All right. What do you think we're gonna do? Where are we starting? Any takers? Any thoughts? We need to find a slope, right? Okay. Hold on. Let's do. So is 625 for every 1,000. So when we're thinking about this, we have our payment equals our K times our B, right? Your payment is going to be whatever your K is times your B. And that's why it's telling us it varies directly. So how that works out, we know that for some K, what can we do? Well, they gave us the information. They told us that if your payment is 625, then that means you borrowed 1,000. Is that enough information for me to already solve for K? Yeah. I have 3 unknowns. I know 2 of them. So can I find for the third one? Yes, I can. So I can go ahead and solve. So we know that 625 equals K times 1,000. We agree? Okay, so then therefore K has to equal what? Anyone besides it? What is K? It's 0.0. Which way did you go? 0.0? Okay, yeah. Did you say 0.00625? Oh, okay, you forgot the zeros.
0.00625.
There we go. All right. So basically, we divide and we get our K. Easy enough? And that's it. So now that you have your K, you can now write your equation. So now we know that our equation is P equals 0.00625 times B. So 625 hundred thousandths times B. Okay. And now it wants to know if I have a loan for 200,000, can I calculate what my monthly payment will be or approximate?
Yes, ma'am.
I can, because I now have my B value. So in order to do that, I have B equals 200,000. So what do? I'm going to plug it in. I now have the equation. I plug it in. And so my monthly payment is going to be $1,250.
Yes, ma'am.
Okay. What tends to get people stuck on variation is that it's word problems. But is the math behind the word problem difficult?
No.
No, not at all. You just have to be willing to read the word problem. Okay, guys?
Wow.
That's the only thing. You need to be willing to read the word problem.
Wow.
Got it?
Did you make the test?
Yes, I did.
Did you make the homework too?
Mhm. Okay, so when I look at the graph, notice how my, as my amount borrowed goes up, what happens to my monthly payment? It goes up as well. Duh, right? Logic. I hope so. All right, inverse variation. So inverse variation means that you are now dividing by your independent variable, okay? So when it says y varies inversely or y is inversely proportional, that means that my x is now in the denominator. Okay, and some situations, it may have it written as y equals k times x to the -1. And when you see that -1, hopefully it makes you think of inverse, like an inverse function. But remembering our exponent rules, if I have a negative power, that means it belongs in the denominator, right?
Yes, ma'am.
All right, so how that looks graphically, it's the first quadrant of the rational function.
Yes, ma'am.
And that's because when we're talking about proportions, inverse, indirect variation, we're only looking in quadrant 1. Because typically, if they're real world situations, are we dealing with a lot of negative situations? No. All right, are we ready to do an inverse variation? All right, here we go. The maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine varies inversely with its length. Okay, experiments indicate that the maximum weight that an 8-foot 2x4 piece of pine can support is 400 pounds. Write a general formula relating the maximum weight in pounds to the length in foot and find the maximum weight W that can be safely supported by a length of 20 feet. Okay, so let's talk about this. Does the size of it really matter? This 2-inch by 4-inch is just, think of it's a noun, right? It's what you're describing. It's what you're dealing with. It's the wood. Okay, a 2x4. It's just the wood. So don't let those numbers confuse you. What is important is that it says you have an 8-foot long piece and it supports 400 pounds. So you have your W, which equals 400, and you have your L, which equals 8. Those are important pieces of information. Okay, and it says it varies inversely. So we know that W equals K divided by some L. do I have enough information to solve for my K value? I do. From reading that word problem, I have enough information. Once I find my K, can I then answer how much weight can a 20-foot piece accommodate? Yeah? So do you see what we did here? Are there questions about pulling the information out and working through it?
Oh, man.
Is Brandon our answer for everything?
Yes, ma'am.
All right, so here we have our solution. So we're gonna go through it. So we've already established that W varies inversely with L. So that's why it's W equals K divided by L. Cool? Then we established that we knew our W and we knew our L. And from knowing our W and our L, we're gonna substitute in and solve for our K. If I'm dividing by 8, what am I gonna do to get K by itself? Multiply. So we know that K equals 3,200. Feel good? All right, can I answer the final question? How much weight can a 20-foot 2x4 hold? Yes, I can, because I now know my equation. So my model is the weight equals 3,200 divided by L. So therefore, I have 3,200 divided by 20 means that the largest that this piece of pine can hold is 160 pounds. So if you weigh more than 160, you're gonna fall into the hole because that wood's not gonna hold.
Yes, ma'am.
It's becoming
Oh, man. No.
all right. So when we look at it graphically, notice how our length increases, our weight does what? Decreases. That wood is getting less and less reliable. All right. How do you feel? Good? All right. So variation parts 1 and 2 are done. Now we're on the last part of variation, which is joint variation. Okay, joint variation means that we have to read the problem to establish what's taking place, okay? So whether it's gonna be inverse first or direct first or direct then inverse, we don't know. We just have to read the problem because it's gonna vary each time, okay?
Yes.
So a student's GPA varies jointly with the average amount of time he or she studies each week and the average amount of time spent sleeping each week, and varies inversely with the average amount of time spent on a social media each week. So write an equation that relates these quantities. All right. So we gotta establish some variables, right? So establishing variables, we know that we are talking about the GPA. So we know GPA equals, and it says it varies jointly with the average amount of time he or she studies each week and the average amount of time sleeping each week. Okay, so we know there's gonna be a K of some sort, right? So our K is in the front. And because it says jointly, I know that that means that my amount of time that I study and the amount of time that I sleep are going to be multiplied, right? So what variables do we want to use for, ooh, they're both S's. We can make S for study and Z for sleep. Get it? The Z's. All right, and then varies inversely. So inversely lets us know that we're gonna have to divide the amount of time spent on social media. So we have social media, M. So I just now created a joint variation. Does that make sense? And that's literally what you're doing. So any other time you're gonna establish your symbols. So we have G is GPA. R for this one was just sleep. F was for social media. Why an F? Because you're gonna receive an F. And then you write the model. Okay. It doesn't matter if your K is in the numerator or leading in the front. Okay. Now with this situation, you'd have to know a lot of variables, right? You'd have to know so that you can figure out your K. So with that information, you then go from there, but it's about just setting it up. So do you feel comfortable? I didn't mean to click. Do you feel comfortable being able to read and set up?
Yeah.
So we identified we read, created symbols, and wrote the model. Doable? All right. So we're going to do it this time, but this time we're also going to throw some numbers at you. Okay. All right. So the force F of the wind on a flat surface position at a right angle to the direction of the wind varies jointly with the area of the surface and the square of the speed V of the wind. A wind 20 miles per hour blowing on a window measures 3 feet by 4 feet, has a force of 120 pounds. What force does a wind of 40 miles per hour exert on a window measuring 4 feet by 5 feet? A lot of words, a lot of numbers. Let's break it down. So we have our force is our first letter, right? The force. Okay. And it varies jointly. So I know it's going to be K times something, right? With the area of the surface. So with the area of the surface and with the speed of the wind. Do you see that? All we did was read and take the words apart. Does it say inversely at any point in here? So that means there's no division taking place. Agreed? All right. So then it tells me, now it's going to give me some information. A wind of 20 miles per hour blowing on a window measuring 3 feet by 4 feet has a force of 120 pounds. So I know my velocity is 20, right? The area is going to equal 3 times 4 because it's a 3 by 4. So that is 12. And I know that the force equals 120. Do I have enough information to solve for my constant? I do. So go ahead, solve for the constant. Check it. Okay, so oh wait, did it say square? Ah, fudge.
Oh, you can tell me.
I didn't see that. I don't know why I forgot that. It says the square of the speed. So our V was squared. That little detail. Lo siento. So it should be what now? The 20? So 400? Yeah. A quarter. All right, so then we plug in. So we have our variables, we plug in and everything goes in. So we end up with 120 equals K times 12 times 400. And we multiply and divide. And you end up with yay, nay. All right. So then it says, the last part wanted us to know, well, what about if you're given this other information? So if the wind is going 40 miles per hour, your window is a 4x5, and it wants to know what is the force. Do I have everything I need to solve for this now? Yes. So now I'm just gonna plug in the given information. So I have my area, I have my speed, so I'm gonna plug in to solve for my force. And it just comes down to multiplying and dividing. So the force of the wind would be 800 pounds. It's a lot of force. All right, questions, comments, concerns about variation?